Hello everyone, welcome to my channel Euclid Mathematics. In my today's video, I will explain to you all one of the important topic from group theory, which is a coset. Coset point, it is important for NET, SET and other multiple competitive exams. That topic it is quite easy, but the remaining topic which a normal subgroup, again after of that factor group, a quotient group, we need that coset topic for these points. As well, in competitive exam, the question on coset topic, it surely comes for every year. So coset topic it is quite easy. We just have to learn it in coset, which is a left coset and right coset. Okay? If any group which is having left and right coset, then we say that it has a coset. Okay. Now let's see the definition of a coset. We are trying to understand the definition of coset first, and then we go for some examples on coset. Okay. Now let's go for the definition. So here the definition of a coset, it says that let H is a subgroup of a G. Okay, I'm having group G and H is a subgroup of a G, and let's consider the any element A belongs to G, then the set. Okay, so I consider one element A from G and H is a subgroup of a G. So A into H. Okay, A into H can be written as A multiplied by H, but that small h which belongs to our subgroup H. Okay, H is a subgroup and small h belongs from H. Okay, so AH is equal to A into H. So this is called as the left coset of H in G. Okay, this is called the left coset of H in G. And similarly for right coset. Okay, right coset it says that H into A, and H which can be written as H multiplied by A, and that H is from subgroup H. Okay, then we say that it is the right coset of H in G. Okay, so that A is from group. Select any element from group and select any of the element from subgroup. Find out their multiplication from left side and right side. If both are coming equal, then we say that it is the coset of our group. Okay, so this one is the left coset and this one is the right coset. So let's see some of the example. Once you saw some examples, you will come to understand how easy that topic it is. Okay, so let's go for the example. So I'm having one property here. If the G is abelian group, that means there exists element xy which is equal to yx. Okay, this property hold, then we say that G is abelian group. Okay, if G is abelian group, then every left coset of H in G which is equal to right coset of H in G. That means this left coset and right coset both are equal. That means A into H which is equal to H into A. When it hold, when our group is a abelian. Okay, when group is a abelian, then left coset and right cosets are equal. Okay, now let's see some of the example on cosets. So I taken here example first, which is a Z6. Okay, group I consider Z6, and we know that Z6 is abelian cyclic group. Okay, abelian it is as well as and cyclic. Okay, and consider a subgroup of H. Okay, subgroup means the element which can generate whole group. Okay, non-repeating generator for our group. Okay, so we can see that 0 is a generator. 0 can generate whole Z6 because it is the identity element. Okay, this one is the identity element because Z6 is a additive group and having identity 0. So identity always generate that group. Again, 2 also is generator of Z6 and 4 also generator of Z6. Okay, so these are the non-repeating generator. That's why we call H as a subgroup of a G. Okay, other you can see other tests for finding subgroup as well. Okay, like Lagrange's theorem. There are other tests are also there that we can check whether H is subgroup of a G or not. Okay, so if you wanted to see these tests, you can check it into my playlist. I added subgroup test in my playlist. Okay, so if you have doubt related to this, you can comment me in comment box. Okay, I will upload a similar video on you as per your doubt. Okay, now I'm having G and H here, and I want the left coset of H in G. Okay, what is mean by left coset? A multiplied by H, and A is from group G and H is from subgroup of G. Okay, so this is called the left coset. So we want the left coset here. So our group is a Z6. Z6 contain 5 element and its subgroup it is here 4. Okay, Z6 contains 0, 1, 2, 3, 4, 5 and 6 it goes to 0. Okay, this is the element which is from Z6. Okay, I'm having H here subgroup of G and G group it is here Z6. Okay, now for finding the left coset we need A belongs to H. Okay, A belongs to A belongs to G. So A belongs to G means select any element from G. So I selected here 0 belongs to Z6, and now next task is that to take any one element from our subgroup. Okay, so 0 plus our subgroup, it will give our first coset. Okay, so 0 plus H. So 0 plus 0, it remains 0. 0 plus 2, it remains 2. And 0 plus 4, it remains 4. Okay, that means our H remain same. So it is our first left coset that it says that 0 plus H is as it is a H. Okay, because 0 is identity element. Under additive, it remain same for other element. Okay, now select second element from G, which is a 1. So 1 belongs to Z6 and add it to the edge. Okay. So 1 plus 0, 1. 1 plus 2 is 3. And 1 plus 4 it is 5. Okay. So this is the second coset. But as we can see here, that coset which is not equal to subgroup. Okay. We want the subgroup as a coset. Okay. But we have here 1 plus h. It is not a subgroup because it is not equal to h. Okay. Now let's move forward further. Okay. Now let's find out next coset. 2 belongs to Z6. I consider here second element as a 2, which is from Z6, and find out 2 plus h. Okay, 2 plus h means this one. 2 plus 0 is a 2. 2 plus 2 it is 4, and 2 plus 4 it is a 6. 2 plus 4 is a 6. But we are looking under Z6. Under Z6, 6 means 0 because that is additive group, and under Z6, 6 is a 0. Okay, you can see it here. I got the next coset 2 plus h as a 2, 4, 0, and exactly which is equal to our subgroup. Okay, which is equal to our subgroup. Okay, this one is the next coset. Now let's go for the third element. So I'm having here 3, 4, 5. So we have to repeat same procedure for the next 3 element also. Okay, now let's go for the 3. So 3 it is here. 3 belongs to Z6. So 3 plus h. 3 plus 0, 3. 3 plus 2, 5. And 3 plus 4, 7. But 7 under Z6, which is a 1. Okay, we are looking under Z6. 7 is not present. So we have to find out after 6 what the number comes for 7. Okay, so it gives 1. 7 under Z6 is a 1. Okay, this is also next coset, but which is not equal to subgroup. Okay, let's go for the fourth element. 4 belongs to Z6. Okay, so which is a 4 plus h. And 4 plus h can be written as 4 plus 0, 4. 4 plus 2, 6 means 0. And 4 plus 4, 8 means under Z6 it is a 2. Okay, so this one is the next coset. Okay, let's go for the last remaining coset for the element 5. Add 5 to the 0, 2 and 4 to our subgroup. So here next element 5 belongs to Z6. Okay, so 5 plus h. 5 plus 0, 5. 5 plus 2, 7 means 1. And 5 plus 3, 8. 8 means 3. Okay, we are looking under subgroup h, which is having element 0 to 4. Okay, so I got the next element 5 belongs to Z6, which has a coset 5, 1, 3, which is not equal to subgroup. Now let's figure it out how many cosets we found it here. Okay, so as we can observe, 0 plus h. Okay, 0 plus h means 0 belongs to Z6. 0 plus h, again 2 belongs to Z6. That means 2 plus h. Again 4 belongs to Z6 means 4 plus h. 3 of these cosets are having value 0 to 4, which is equal to subgroup. And remaining 1 plus h, 3 plus h, and 5 plus h. Okay, this is the 5 plus h. All 3 of these are having same value 1, 3, 5. If they are altered 5, 1, 3, it changed to 1, 3, 5. It doesn't matter. Okay, so it remains same. So here we can see we got the 2 coset here, which is the first all are equal here and second all are equal here. Okay, so by observation of these 2 coset, we can say that here 0 plus h and 1 plus h are 2 distinct coset of h in G. Okay, these are the 2 distinct coset. That means they do not have any common element between them. Okay, so 0 plus and 1 plus h both are the distinct coset. Okay, different, both are different. Okay, and if both are different, that means their union, it gives our whole group G, and their intersection always gives empty set, because this one is a different and this one is a different. Their union, it goes to our Z6, and their intersection, it remain 5. Okay, now here second property, it says that their first it is here, their union is Z6. Okay, we can see it here, and their intersection, it remain 5. Okay, so by conclusion of this, we can say here I have first property, that if h and bh are 2 cosets, these are the 2 cosets of h in G, then we can write their intersection as 5. Okay, their intersection as a 5 and their union as a group G. Okay, or h is equal to bh. Okay, this one is the first example from the cosets as a left coset and right coset. Okay, so I hope so you all have understood the meaning for left coset and right coset. Firstly, I explained here the definition of a coset, and after that I explained here the left coset and right coset along with the example. For similar video, you can check it into my playlist. I uploaded more videos there, and if you have any doubt, you can comment me in a comment box. I will upload videos as per your doubts. Okay, so thank you everyone. Thank you for my today's lecture.